and non-A not is non-A. We say for all A in the set, A and not A is self-contradictory, of course, with respect to this way of representing the if-then. Then, what is here most important is to remember that this is fixed, but I should find a relation allowing me to verify this inequality. Okay, good. What with the principle? This is for the principle of non-contradiction. But what with the principle of excluded meaning? As I told you, Aristotle was a little bit vague on that. Let me remember one thing. In metaphysics, Aristotle says that the principle of non-contradiction is not susceptible to demonstration. It's not susceptible to demonstration. Well, his idea is that if we try to demonstrate, we will try to demonstrate the principle, we will meet the principle. Okay, probably this is true. But after formalization, I am not so sure. Okay, what about this excluded middle principle? Well, I will take it in the former way of A or not A is always. And a way to use my relation of self-contradiction, I will write this in this way. Not A or not A is self. Remember that this is a jump. Here that there is no jump, and here there is a jump. First, I say to you that Aristotle write the principle as not A and not A is. Later on, this is translated, of course, supposing duality, it is not A or not A, supposing duality and the characteristic of a strong negation of the not, this is translated by not. And in my case, what I take is the negation of this is self-contradictory. That is, I will need quartet, sets representing these statements, plus representing or, prime representing not, and a relation representing if-then. Because what I should represent is if not A or not A, then not A or not A. Then what I should to study is A or not A not is related with A or A not or all A in A. I am not supposing that prime is a strong negation. Then I am not supposing at all that this is the same that A or not A. I am not supposing that this is traced out. What I should work is here. Not strong negations are not so common. There are not strong negations. There are intuitionistic logic. The negation is not strong. And for example, in prologue, the negation by failure, it is not strong. There exists. Which is the problem of non-strong negations for fuzzy sets? The problem is that not strong negations are discontinuous. This is the problem. Are not continuous functions. And in fuzzy sets, we don't like to have non-continuous intersections, unions, and negations. Why? Because one of the strengths of fuzzy logic is to consider continuous functions. Sometimes functions are not continuous. For example, if we deal with a fuzzy set and a crisp set, the crisp set is not represented by a continuous function, of course. But if we combine fuzzy sets by a discontinuous function, we will introduce discontinuities that were not in the problem. It's for that we don't like to work with a non-continuous denorm, a non-continuous ticonorm, and a non-strong negation. Because non-strong negations are not continuous. Then, in considering the complement of mu, we will add discontinuities that were not in mu. We don't like that. Okay? But in general, I should consider that negation is not necessarily a strong one. And I should study this. Okay, this is what I should do. And now we have a very stupid result. Look. Very stupid two results. The principles can be proven. First case, no contradiction. Suppose I have this situation. Take, no, excuse me. Suppose I am in this situation with the intersection and then define this relation. Remember that a relation is nothing else than a subset of the Cartesian product of L by itself. A family of couples, pairs. Okay, define this relation. The set of the pairs constructed in this way for all A in L. It's obvious that this set verifies the principle of non-contradiction, in my style of course, with relation. It's obvious. Okay? Let me say a little bit more. Imagine that there is another relation that also verifies the principle of non-contradiction. Of course, this relation is included in this relation. Then this relation is the small relation with which this couple verifies the principle of non-contradiction. Okay? In particular, it is clear that this relation should be the intersection of all these relations verifying the principle. Okay? Then, this is a very stupid theorem. Yeah? Even a couple of triple L intersection negation, there is always at least one relation, this, for which this verifies the principle of non-contradiction. Second stupid theorem. Suppose the principle is with the middle. Suppose I have a triplet like that. This plus represents or, prime represents not. Consider this relation. Relation considered by the pairs, which is A, the first part of the pair, the couple of the pair is that, and the second component is this one. Of course, with this relation, the principle of the middle is automatically verified. Of course also, if I have another relation for which the principle